Alright, okay, this is the exercise on the general waves properties, and it's exercise 12.1. So the first three questions are rather easy. This can be found in your textbook answers. So what is carried by the wave is energy. Second question, okay, name the type of wave which moves at right angle to its disturbance. Give an example of this type of wave. Okay, again, this by definition is actually transverse waves. Transverse waves, example, okay, there are a lot of them: light waves, electromagnetic waves, water waves, etc. and etc. So for question 3, name the type of waves which moves parallel. Okay, so now the keyword here is parallel. Okay, parallel to the direction, okay, to the direction as its disturbance. Give an example of this type of wave. Okay, this type of wave is actually called longitudinal waves. And okay, an example that you have learned is actually sound waves. Okay, so please take note of the keywords: moving parallel to the direction, okay, as its disturbance. Okay, this one is moving at right angles, or we can say, okay, is moving at perpendicular, okay, to its disturbance. Okay, so this for the first three questions. Okay, now for question 4, a lot of you simply left it blank, or you just thought that the two graphs are the same. Okay, and how you all draw the amplitude and wavelength are actually similar. Okay, so over here I want you all to listen very carefully, and because this is quite important in differentiating, okay, what are the differences, okay, between the two graphs. So in question 4, the question says, figure A, okay, which is this figure, shows how the displacement of a wave changes with distance, while figure B shows how the displacement changes with time. Okay, so these are two different types of graphs. Okay, mark in the diagram of the following terms: amplitude, wavelength, and period. Okay, so the first graph shows that, okay, is displacement against distance. The second graph is displacements against time. So take note of the axis, the labeling of the axis. So the first one is displacement against distance. Okay, second one, displacement against time. So what are the differences? So in the question, they are asking you to find the amplitude, the wavelength, and the period. Okay, so amplitude is rather easy. Amplitude is the maximum displacement, okay, to its initial position. So this is the amplitude, or you can even label amplitude over here. Okay, this can be counted as the amplitude. Okay, same thing over here. Okay, this is the amplitude from the maximum displacement, okay, to its original position. Okay, all these are actually amplitude. Okay, now wavelength. Okay, for the first graph, most of you can get the wavelength. Okay, but take note of this. Okay, wavelength can only be found in a displacement distance, okay, graph. Distance, okay, what is the SI unit for distance? Is meters. Okay, what is the SI unit for wavelength? Okay, wavelength, we are trying to find the length, and we know that the SI unit for length is actually meters. Okay, so to find the wavelength, you have to find it in this graph. Okay, you cannot find wavelength, okay, in the second graph, because the second graph, the axis over here is time, and for time, the unit is actually seconds. Okay, the SI unit is actually seconds. Alright, so wavelength, how do you find the wavelength? By definition, okay, it can be between two crests. Okay, so this can be one wavelength. Okay, wavelength, we use the symbol lambda to denote it. This is actually one wavelength. Okay, so the second way to find the wavelength is of course, okay, from this point to this point. How do we know it's one wavelength? So this is half a wave, and this one is half a wave. So add together is one wave, and we know that, okay, the distance for one wave to occur is actually the wavelength. Okay, so we can actually label this as the wavelength, or we can label this as a wavelength. Okay, or between the two trough. Okay, this can be one wavelength. Alright. Okay, so please get this clear. This is very important. Okay, next thing, they are trying to ask you to find the period. Okay, now, what's the definition for period? Okay, the period is the time taken for one wavelength to occur. Okay, it's the time taken for one wavelength to occur. Okay, so over here we can find period in a displacement time graph, but we cannot find period in a displacement distance graph. Okay, because period is actually time. Okay, period is related to time. Okay, so for period, the SI unit is also seconds. So we can only find period under a displacement time graph. Okay, so it's the time taken for one wavelength to occur. So where's the one wavelength? Okay, as seen over here, the one wavelength is this thing. Okay, because this is half a wave and this is another half a wave. Add together is one wavelength. So the period is actually from this point to this point. Okay, over here. Okay, from this point to this point is the period. So actually you can read off from the graph. Okay, what's the value? Okay, for the period. Let's say over here is 10 seconds, then the period is 10 seconds. Okay, if it's 5 seconds, then the period will be 5 seconds. Okay, so another way to find period, of course, is between the two crests, same thing as the wavelength, but now we are trying to find the period, which is the time taken for one wavelength to occur. So we can also measure this thing, and we can take the difference, okay, between the time, okay, and you can know the period. Okay, for period, the symbol is T. Okay, period. Okay, symbol is T. Okay, for wavelength, the symbol is lambda. Okay, so this is for question number 4. Alright, okay, now for question number 5, define the following terms: amplitude, wavelength, and frequency, and also period. Okay, the definitions can be found in your textbook, so I'm not going to go through it over here. Alright, so please memorize the definitions.